Understanding neural networks, the building blocks of AI. One simple way to think of AI is this: humans using data to train machine learning algorithms on computers with lots of computing power to solve a specific task. But what does that sentence really mean? Recent successes in AI technology can be attributed to several phenomena that are closely related to these four building blocks: the rise of the internet, social networks, technological breakthroughs, and significant theoretical advances in science. To have a real understanding of these building blocks, the following have to be considered. Why do they work together now? Why couldn't they work together before? And what else has made them a success today? Data. Nowadays, the word data appears in many job descriptions on recruitment websites. In fact, plenty of people now work almost exclusively on data-related tasks. They collect it, transform it, visualize it, store it, and sell it. Indeed, data is said to be the world's most valuable resource. One of those reasons revolves around AI, which needs data to learn. Data can be recorded by humans, sensors, machines, and apps. But what does it actually look like? Every observation we make holds information, and once it is recorded, either on a piece of paper, a hard drive, or a photo, it becomes data. Data is the recording of information in a quantitative and qualitative form, which is stored for later use. In fact, the terms information and data are often used interchangeably. For humans or AI to learn from data, it needs to be representative and exhaustive. A quality and quantity approach is needed. If not, the learning process will most likely be compromised and lead to results that are inaccurate and biased. For example, an AI system trained to predict the weather will not be able to give accurate forecasts of a cold winter week if it has only been given data from 2 weeks' worth of summer weather patterns. It has never encountered a full seasonal cycle in the learning process, so it would have a hard time finding patterns of data related to the whole year. However, a single year with a rainy summer would not be representative either. So ideally, we would want to have more samples from several years. As a matter of fact, even simple algorithms can perform complex tasks with ease if they are given sufficient data to learn from. Increase the amount of data, and you will see an increase in performance. It shows to a certain extent that the data is more important than the complexity of the algorithms used to train an AI system. This is often called the unreasonable effectiveness of data. The name comes from the title of a research paper about this observation too, which also gave birth to the phrase big data. This effectiveness has become more apparent in recent years as additional data is available thanks to the rise of the internet. Billions of people now share and access information every day. Data, though, has also received a helping hand from recent significant advances in how we store it. Back in 1956, you would need an IBM RAM-AC 305 computer, which weighed over a ton, to store just 5 megabytes of data. That's roughly the size of a 6-minute song. By the 1980s, you could store the exact same amount of information using 4 floppy disks, weighing in total around 100 grams. Needless to say, today's standard SD memory cards weigh 2 grams and can store more than 128 gigabytes, over 25,000 songs, 3 on a piece of plastic the size of a stamp. According to a report from consultancy firm PricewaterhouseCoopers, and as seen in this infographic, the accumulated digital universe of data in 2020 totaled 44 zettabytes. 1 zettabyte equals 1 million gigabytes. But the quality of data is just as important as the quantity. Take our previous example. A system trained with weather data from Switzerland will not be able to forecast weather in the Sahara Desert, regardless of the amount of historical records at its disposal. The AI system would have never been exposed to temperatures above 40 degrees Celsius. It is biased toward the Swiss mountain climate, and wouldn't generalize with climates it doesn't know. And that would be an issue even if decades of historical records were available. Similarly, an opinion poll conducted at 3 p.m. on a Thursday afternoon in a park is not representative of the overall population of a country. The people interviewed are likely to be senior citizens, parents taking care of their children, or people working from home or night shifts. The poll will almost entirely exclude the large part of the population that works a typical 9-to-5 job. Given the importance of data and the integral role it plays with AI, we will cover these aspects in more detail later. Data comes in many forms. Now though, let's look at algorithms and tasks. Machine learning algorithms and tasks. Machine learning algorithms, whose foundations lie in statistics and mathematics, are the blueprints of how learning takes place. These algorithms, also referred to as models, analyze data in an agile way to find the best method to execute a task successfully. This process of finding the best setup, based on patterns found within the data, is what we call learning. More than just a program. Discussed how modern machine learning algorithms differ from static, human-written, rule-based algorithms concerning their ability to learn from data and the patterns within it. Machine learning algorithms will iteratively change how they operate to improve their performance. This process is known as the learning phase or training phase of the model, and it is quite similar to how humans learn. A good analogy is a driving license theory exam, where a student has to decide what actions to take in a series of real-life driving scenarios. One way to prepare for the test would be to take lots of practice quizzes and learn from their feedback. By being exposed to a wide range of possible situations, the student could improve their understanding of the traffic rules and thus be better prepared for that final test. However, the final test questions would then need to be sufficiently different from the practice quizzes to ensure that learning by heart isn't a viable strategy. Training a machine learning algorithm happens in exactly the same way. In the first step, the model is trained on one data set, called the training set. Then in the second step, it is evaluated separately on another, unseen data set, called the test set. The ultimate goal is for it to perform equally well with the training set as with the test set. This ensures the model did not just memorize the details of the training set. It needs to prove it can handle new, unseen data equally well. Why training models isn't so straightforward. So how can models learn? And how can they be trained? Well, let's take our earlier video, Peek Behind the Curtain, as an example, which looked at how to predict the weight of children using their height and other features. In that story, our simple model had one internal parameter, a numerical value, and the model had learned the best parameter value of 0.35 directly from the data. For some models, this direct approach to calculating the best parameters exists. Another way to identify the best parameter is through repeated feedback and by making incremental improvements. You could start from a random parameter value, let's say 0.1, which we saw leads to a fairly poor performance from the model. But if you gradually increase the parameter, it would eventually get close to the optimal value of 0.35 and therefore improve the model step by step. There is potential to initially overshoot a bit, but that would reduce the performance of the model, meaning footsteps would need to be retraced to reach the optimum value of 0.35. Firstly, it provides our target, the true weight of the children, and secondly, we use it to make predictions with our interim model. That way, we can calculate by how much our predictions are off target and hence assess whether our model improved. What do you think of our video? Let me know in the comments section below. Before you go, please hit the like button and subscribe to my channel. Thanks for watching.